All right, recording is rolling. Oh, let me share. I present my screen. Yeah. Okay, so let's go on. All right, and you guys have been signed up to this Google Classroom code right here. Near the end of class today, I will pull that page up and we'll look a little bit at the files that are already there. But like this class recording will eventually upload to that too, so you'll have access to that. Right. So I got to cover a bunch of first day stuff, like hall passes and evacuation stuff. So yeah, let's go ahead and knock that out. Now, you guys probably remember how the system works from last year. Unless, I don't know, unless you just either moved to Florida or something like that. So here's what's going on. You guys see this laptop right here, this laptop station? It's not screen see it right now, but that looks like that. Okay. Then you guys see this barcode scanner right next to it. Right, so the way this is working is if you need to pass somewhere, say for example, you need to go to the restroom, right? Then what you do is there's a drop-down menu here that has every single student in it. There's like 2,300 students. So if you start typing the first letters of your last name, I should navigate to really fast. Okay. Then you have two choices of destination. Now, the one you're probably going to click most of the time is this one on the right. It has the building on it. It says destination. And there's just a handful of options. There's restroom, there's media center, guidance, right, things like that. Right. And then you can log out. Or if you need to go to another teacher's room, it's, oh, dang, I left my lunchbox there. Sorry. Then this person looking character. So click on that one, then you should be able to find your teacher's name and then go there, right, and then sign out. Right. Then the system will know that you're wherever you say you're going. And then when you come back, you probably have an ID card. You guys have a student ID card. You guys bring those. You should be able to scan it right here, and then it should log you back in. Now, I do remember last year that didn't always work very well, but I think they made some patches over the summer. I think they updated and fixed some things, so that should work. But I guess we'll find out in the next few days. Right. But if that doesn't, if the scan thing doesn't work, you can just like manually sign yourself back into class. Right. But that's what we're doing for hall passes. So if you need to go somewhere, put that thing, efficient for everybody, and there you go. Okay. All right. Evacuation drills. So if the fire drill rings, what's the first thing we're gonna do? Yeah, wait. I guess everybody got that because yeah, I heard nothing. That was the answer. Nothing. Yeah. So we're gonna wait right here because they're gonna tell us one of a few things that we could do. There's gonna be lots of options that open up. So they might say shelter in place, in which case we just like hang out in the classroom and just like avoid hall passes. They might say lockdown, in which case we're lucky because we have those lab tables back there. So if they send us lockdown, we're just going to go back behind the lab tables and just wait for a few minutes. If they actually do send us on a fire drill, then what we're going to do is go out these doors. We're going to hang a left, go all the way down that hall. That don't normally exit that way, but that's where we're going. Okay. And then I'll meet you guys outside. You guys see Griffin on a stick? Griffin on a stick? Oh yeah, that's under this camera right here. Griffin on a stick. So if you're trying to find us, then you should see this coming around. You guys can find me. But where are we going? Well, there's one of two places they could send us. Okay. So if they send us to evac site A, that's the bus loop. Oh, hey, look, that's our building. Look, notice we've taken a left. We're going out these doors, right? And then we'll go to the bus loop. Now here, what they want us to do is to line up in straight lines. My number is 29, which is right about where you see it there on the map. Right, so go back to here so you guys can see for context. Here's our building. My room is really close to where that cursor is. This is building 3. All right, here's the doors. We'll go out. And we line up in a straight line, like pretty much right here. Okay. Or if they send us to evac site B, this is the football field. Right, so let me go back to the map to point out where that would be. So if they send us to this here football field, okay, because we are a science class, they have us organized by subject. Right, we're going to go all the way along this home side of the field to this corner right here. Use the northwest corner right here. Right. So that's where we're meeting up. Let me show you guys what that looks like on the map. Right. I think it's maps upside down, like south is up. But okay, so you guys know we're going to come in from the bottom left corner of this map, go all the way down the field, and line up right about here. Okay. All right, who has any questions about evacuation? Any questions? Okay, you guys good? Aha! All right, now we're ready to start talking about this class, physics. And so, yeah, I want to take a sort of a history angle on this. Like, where does this class kind of come from? Okay, so what What picture are you guys looking at right there? What is that? Tree. Yeah. All right. Good call. Now, why am I showing you guys a tree? What tree do you think that is?
Newton's apple tree.
Is that Newton's apple tree? That's Newton's apple tree. That is the tree. That's the tree that, well, at least why you guys are sitting this past 2 days, maybe with air conditioning and protection, because how could any of modern technology exist without industrial revolution? And how could that exist without the laws of physics? So the story here is, let's go back to, say 1666. Now, Isaac Newton, we're talking about, okay, so other context, right? We're talking about hundreds of years ago where there was, modern science did exist, but it had just been developed. Like it was just coming around, like as a concept, like this whole idea of like, oh, there might be different ways things could work. And hey, let's come up with hypotheses and actually test things out, record data, right? Like that was sort of a new concept in human history. And so people knew kind of how some things work, but let's say physics hadn't quite been around developed at this point. Isaac Newton was slated to become a farmer because his parents were farmers, and like back in the day, you kind of normally just did whatever your parents taught you how to do and just took on that trade. But he wasn't really good at farming, was pretty good at math, so he eventually went to college, which not very many people did back in the day, right? So one of the lucky few. But there was this pandemic in 1666, so they sent everybody home. I mean, kind of historical pivot here. We're talking about so long ago. I mean, modern science is just developing at that point, that there wasn't even really a germ theory of illness, so they didn't really know what was causing the pandemic. But they did kind of know, kind of separate out everybody, so they sent everybody home. And Newton is, he's one of these people who's like super curious about like how does everything in the world work, and kind of lay down the laws for it. Right? So he's maybe looking out that window of that house in the back. That's his house in the back, by the way. Maybe looking at that apple tree right there and sees this apple fall. And then he has this epiphany. So supposedly he's the first person in history to make the connection of that an apple falling from a tree and the moon orbiting around the earth is actually caused by the same phenomenon. See, like before Newton, people said, okay, well, we've got these terrestrial laws and there's celestial laws, and we don't know how any of it works, but we just see these two different things happening. See, like, right? But Newton says, oh, hold on a minute. Actually, that's all part of the same thing. I think the moon is sort of falling around the earth, just like that apple fell down straight. Right? So then he spends the summer figuring out what the basic laws of physics are, what laws of motion, what are the laws that kind of govern how everything works. He needs a whole new branch of math to back up everything. So he sort of invents calculus on a whim just to back up all the physics laws he's come up with. Anybody here in calculus? Who's a calculus or taking calculus? Oh, quite a few guys. All right. That will sort of help you out in this class in a few ways. I mean, don't worry about it if you're not taking it. You're fine. But that is there's a lot that just goes hand in hand with physics and calculus. A lot of the graphs that we do, I'll point out as we go on. Oh, this is actually a calculus application, so you can know look for it. Like, oh yeah, it is. Okay. And then what does he do with all this? Because I mean, at this point, like this was summer 1666 that he kind of like invents, or lays down foundations what's going to come everything in the modern world. Well, to him, he was saying, okay, well, this is something I'm personally curious in, personally interested in, but I don't know who else is going to be interested in like the laws of the universe. Right? So he ends up just like shuffling these papers under his bed and like forgets about them, and like many years go by. Then there's this comet that rolls by. Oh, since I'm talking a little bit about astronomy here, it's gonna be an astronomy tie-in. You guys know that we're about to go into a meteor shower in the next few days? Yeah, the Perseids, right? It's been going on a few thousand years now. So I think it's August 11 to 14. I saw different dates on that. So yeah, look at the night sky here in the next few days. Might see some shooting stars, make some wishes. But by this point in history, people had figured out that the sun was at the center of the solar system, not the Earth. So the Earth goes around the sun. So they knew that. Right? They also knew, because this guy, a couple guys, Tycho Brahe and Johannes Kepler, that the planets don't actually move in circles; they actually move in ellipses. So they had known that before Newton comes along. Right? But they didn't know why. They couldn't figure out what's causing this elliptical motion. Why did they? Right? And then comets have a highly elliptical orbit, so they get really close to the sun and they shoot off way far away out by like Pluto, and they come back. Right? And this comet here, does anybody know the name of this comet?
Halley's Comet?
That is Halley's Comet. Yeah. Now, it wasn't called Halley's Comet at the time, but there was a guy named Edmund Halley who was trying to crack this problem with a bunch of other people at the same time. And 1780s, it shows up again, and there had been this historical record, like, oh, every couple hundred years, this comet keeps showing up. Right? So they knew it was there. They kind of figured out what its path would look like. Again, they don't know the physics or the mathematics of what's driving it into this motion. So Kepler and a bunch of, Halley and a bunch of other like early scientists at the time trying to figure this out. He hears about this eccentric guy named Isaac Newton, teaches math over Cambridge. So, okay, I'll go talk to this guy, see if he has any insight. It's like, hey, can you figure out like have any insight as to this problem that everybody's trying to solve? And Isaac Newton said, oh yeah, actually, I cracked that years ago. I figured out the laws of motion. I've got this inverse square law of universal gravitation, and I've got this math that I came up with called calculus to back everything up. And put it all together, and voila, you get these elliptical orbits. And right, so Edmund Halley here is having his mind blown. Like, are you kidding? Like, everybody's trying to figure this out, and you just like figured this out on a whim years ago and just like forgot about it. So you got to publish this. You got to put this in a book. So Newton takes a couple of years and eventually does publish I'll call this Principia, has a longer Latin title, but this is like the foundation of both this class physics and also calculus. Right? So it all goes back to this book here. And here's Isaac Newton's original handwriting. They have copies of this book available over at the Royal Society over in London. If you're ever in London, actually, might even possibly be able to get your hands on it. Yeah. So, does anybody know what language this was written in?
Latin.
That is Latin. Yeah, because that was sort of the language of science back in the day, right? It was Latin. What is the language of science now? Like if you go to CERN over in Switzerland and talking to a bunch of particle physicists, what language is everybody speaking? You guys gonna say English? Let's go with English. Yeah, English. So yeah, nowadays like English is like the language to know. Sort of become like the default international language at this point, including language of science. But yeah, back in the day, it used to be Latin. So I guess they should have just written this thing in English all along. But there you go. Right, so yeah, so there's sort of the origin story of this class. Now, of course, Isaac Newton, there's some physics before him, and there's been a lot of development since him. But he's sort of like the focal point of where everything really gets going. Right. So what is this class? What is physics? I think it's a pretty good definition here. We're talking about the study of the laws of nature that govern matter and motion in the universe. Okay. So what are you going to use this for? Now, if you already have a really good interest in math and science, and maybe you just like solving puzzles in general, I think you guys are going to really enjoy this class a lot. I've always enjoyed this class. I really enjoyed this class as a student and enjoy tutoring it, enjoy teaching it. If you are going to go into physics in college, obviously you're going to want this class. If you're going into engineering in college, you're going to use this class every day for the rest of your life. But I've got like 30 different students in here, 30 different life stories. I bet some of you guys have ambitions of, maybe we're going 30 different directions, right? So what's going to be the connection? Now, I want to make a point here in the next couple slides that everything sort of connects to everything. I know that the way that school is presented to you is like, okay, well, I go to all these classrooms and I have like in this room, I do history, and then I switch to this room and I do math, and then I switch to this room and I do science, right? But the real world, everything is much more interconnected. A lot of new ideas and developments that come around really have to do with like, making connections between these different topics that are presented to you in school as like individual topics, right? I think Einstein was saying that like playing a violin and being into music helped him develop the general theory of relativity. Like, what's the connection? Well, it's just like certain neural pathways in your brain just makes this connection. He plays the violin, it's like, okay, relativity makes sense, right? So, I mean, what better tool could you have in your back pocket than knowing like the rules of the universe, like how everything works, and that's what you guys get to learn in this class. Do you guys see a bunch of little squares here? Bunch of little squares. How many squares wide is this? How many do you see? 52. 52. Good call. Yeah, I know my projections. It's a little bit smaller than projected last year. Need some switches how this thing presents. So sorry if the font's kind of small. Yeah, 52. Oh, if there's 52 squares wide, what does each row represent? one year, right? So each box is a week, right? Right. So by the time next Wednesday rolls around, you can check off one or more of those boxes. Ooh, that's not a lot of boxes, is there? Yeah, life flies by pretty fast. You guys are probably near the end of this gold band that's labeled high school. And yeah, hopefully you're thinking about now questions like, what do you enjoy doing? What skills do you want to develop? Uh, what career do you want to go into? I think this here is a pretty good framework for maybe trying to narrow that down. Hey, what are you good at? Uh, what do you really love doing? What is it the world needs? And hey, what can you get paid for? I mean, if you could check all those boxes, you're probably pretty good in life, right? I mean, this isn't the only framework to figure things out, but I think it's a pretty good one. Okay. And then, oh yeah, let me hit the second bullet point here. What skills do you want to develop? Because you guys know how like little kids can just like pick up a language just by having it spoken to them, right? That's because they have a lot of brain brain plasticity, right? And then the older you get, the less and less plasticity you get, right? Probably heard that's very good. Can't teach an old dog new tricks, right? So, but yeah, your brain has they're sort of like in your early mid 20s, where it's still still developing. You have a pretty good amount of plasticity. So if there's like anything that you really enjoy doing that involves like skills that you really want to pick up and develop, yeah, you're still in a good period in your life where you can do that. You have have that ability. It just takes takes the effort of actually going through and developing these skills, right? And how is physics going to connect to whatever it is you're interested in? Okay. Again, obviously, if you're going to engineering, I think this class is going to be fundamental to everything you do from now on. But what if you want to do like anything else? What's the connection going to be? So I want to share a story with you guys. I'm going to steal a story from somebody else, a guy named Steve Jobs. You guys know Steve Jobs? Bet you guys do. So you guys have a favorite Pixar movie? Who founded Pixar? Steve Jobs. Anybody have an iPhone? So go through Apple. But I bet you have a smartphone, right? Have a smartphone? Yeah. Well, okay, so iPhone was the first one. So I think kind of follow that. Yeah. So Steve Jobs, this guy back in 1970 started creating the first personal computers and did all these other things afterward. Okay? And his story, well, part of the story is when he graduated high school, he didn't really know what he wanted to do in life exactly or where things were leading. He did start to go to college, but his parents were really poor and he saw all this tuition money going to pay for these classes that he wasn't really sure exactly where things were going, what he was going to do with this. So he ended up actually dropping out of college. He never actually graduated from college, never had a college degree. But what that enabled him to do, this actually ended up working out for him, is he was able to drop in on classes that he took just because they looked interesting, which is a really nice thing that you can do if you ever get a chance to go to a four-year university, like big old campus. I enjoyed doing this a lot too. Back at university, was some of these lecture halls have like hundreds of people in them, and you can just like sit in the back and hang out, and nobody will know you're there, and you can just like learn stuff. And that's what you would do. Just like, oh, well, that looks interesting. I'll just go and sit down in that class. That looks interesting, right? Never received credit for any of these things. But one of the classes that he dropped in on, just because he was curious about it, was a class called calligraphy. What is calligraphy? Yeah,
It's like special handwriting.
yeah, handwriting, the art of fonts, right? That sort of thing, like very artsy kind of class, right? So okay, so art of writing. That like, what useful application is that ever going to have to anything, right? And at the time he's sitting in that class, it's like, well, there was no apparent connection to anything, right? He has no idea. He's only taking it because it looks interesting, right? But many years later, as he's developing some of the very first personal computers, one of the many problems that he and his team have to crack is, well, how do you create a legible font on a pixelated screen? And then that's where he's, aha, I remember a lot of these principles of like font design that I picked up in that calligraphy class, and incorporated a lot of that knowledge into creating like some of the first personal computers. And again, that was like one of the many problems they had to crack. So you might even have enough life experience at this point in your life where you can start to see things like this, like, oh yeah, I did take that class, or I read that book, or I came across this internet article, or whatever. I found this pivot of knowledge that like weirdly enough actually ended up being useful like somewhere down the line, and you can't really connect the dots going forward, but you can in retrospect. So, oh yeah, well, it was really good, I read that book, or it was really good, I took that class, or or really got something out of that, because it's now I can actually use that. Again, what are you learning in this class? Like the laws of the fundamental laws of the universe, right? So it's got to fit in somewhere or something. Right? So habits, you guys know habits are hard to break. Right? That's kind of what a habit is, right? You get into a routine, and then sort of inertia takes over, right? So I mean, if you were in a habit of like I'm going to go home and then just like ignore all my schoolwork and like scroll through Twitter or something like that, right? I mean, after a few weeks of that, you get comfortable with that, and then if you did want to get back on track, it's like, no, actually, you do want to be a really good student. Let's say by like September, October, you make that decision. Now it's extremely hard to make the switch and actually become a good student. Right? But if you take like the next few weeks here, right? I mean, like day one of school, all of us right now have like stress hormones going, and we're trying to figure out like, but what's my schedule and where am I sitting, and I don't know where I'm sitting my next classes, right? Right now is like the perfect, like the best opportunity time, like anywhere in the school year, to figure out like, okay, well, what do I want to get out of my classes, and what kind of student do I want to be, and what routines do I want to establish for myself? How long does it take to establish a routine? About 3 weeks, it seems cited somewhere. So if you take like the rest of August and really make a dedicated effort to live up to like what kind of student do I want to be, right? Last bullet point there, like use a planner, right? I'm going to use a planner and make myself a checklist. I'm going to do things, right? Get the most out of my classes that I can. But then by the time, let's say like mid-September, October rolls around, you will be on that routine where it would be weird to do otherwise. Like if you actually went home one day and said, you know what, I'm just going to throw all my stuff to the side and just roll through Twitter or whatever, right? That would feel weird. Be like, oh no, this is wrong. I've seriously got to like do this thing I've been doing all along. Right, so like, why do you do what you want to do, or why do you do anything? You know, what governs any of your decisions? Maybe that's a nature nurture question, right? But I think a lot of what governs decisions is just like inertia, just like, hey, you know, I've been this person, I've been doing these things, like, and you know, this is just like my routine. It's just the way I do things. And again, like now is like the best time to figure out, you know, what kind of student do I want to be, what routines do I want, you know, make an effort next about 3 weeks, and then you get into a good routine and get a lot of good stuff out of all your classes. Right? There's yeah, using a planner is one of the best piece of advice I can give to you guys. I use a physical planner, like old school. I don't know if you guys like use cell phones as a planner, but have some kind of checklist where you know, end of the day, I'm exhausted, I've forgotten a lot of stuff throughout the day, but you can pull up that checklist. Like, oh yeah, that is right. I do have like these like 5, 6, 7, 8 things to do, and just go check, all the stuff that I need to get done. Okay. Here's another good piece of advice for all your classes: positive framing. So suppose you have some assignment, this class, another class, who knows what the assignment is, right? If you really enjoy the class, then hopefully that positive frame sort of naturally comes like, oh wait, I can't wait to like sit down and like solve these physics problems that are like really enjoyable to solve. Guys like solving puzzles in general, crossword, Sudoku, you can totally use that part of your brain in this class. Like, oh, I'm just, you know, laws of nature, not going to just you know, insert those and solve these complicated problems, and this is a lot of fun, right? And if you enjoy stuff, then hey, you're already doing things right. Now, you know, everybody has individual, you know, unique interests, and you know, hey, you know, good chance that at some point, some class, some assignment, like not my favorite thing to do. Who knows what that is? Probably writing English essay. Probably not this class so much. This is a fun class. But the focus on the two. Focus on like as a matter of metacognition, what feelings are evoked by, you know, whatever's in front of you, that and notice it and pick up on that. And if you actually notice that, like, I have this feeling like, oh, I'm not enjoying this. I really don't want to do this. Think, you know, step back and see that almost like third person point of view. Think, oh, hold on a minute. Now, if I had this attitude of like, I'm just hating life right now, you know, that's not helping me like finish this assignment, which is going to get done one way or another. So, hey, you know, maybe if I can find something enjoyable in this, or if I can apply some kind of positive framing, or if I can think, you know, what do I really want to get out of this, and you know, just like pick some kind of nugget you can get out of something. You know, hopefully that'll help you like maximize the opportunities that are in front of you, and you can actually have a really good school year. Right? Dunning-Kruger. Okay, so we all have human brains, and human brains, well, they're good for a lot of things, and there's also a lot of tricky things about them. And this is just one thing that it's one of these things that I think it's good to know about. Again, this is like metacognition, like how does my own brain work? Right? So, some of you guys might know what this is. There's two takes I want to do on this. Let me start with the most common one, then I'll tell you guys a more nuanced one later. Right? So, what are we looking at? So, from left to right, left is like a novice at, I don't know what data exactly applies to this graph. There's some missing information here, but we're just going to roll with it because the story is right here. And so, if you're far left on this graph, what that means is you don't know very much about, who knows what subject was applied to, like this test here, right? Maybe you know a couple of tidbits. I know 2 or 3 things about the thing, right? Right. And then as you get further and further to the right, that's like, you're taking more classes on that subject, you're reading more books on that subject, you're learning more about that subject, right? The more you learn, the more you know. And so that green line says actual test score. Oh, well, that's basically a 45-degree line, right? The more you learn, the more you know, you take the test, voila, right? Kind of makes sense, right? Right. I can tell you guys too that I know you guys aren't AP, but the AP physics test is it's like the hardest test of all the AP exams. And having seen so many students go through that class, I've seen like this direct correlation myself, where it's like, if a student spends more time with the subject and thinks deeply about the subject material, like they pass, even if they aren't really good at math naturally. And if they kind of slack off and cut a bunch of corners, then they fail. And like that's really all it is. It's just like a matter of effort, like how much time do you put into something. Okay? So that's the green line. Now the red and blue lines are basically the same lines. I'm going to treat them as the same thing, right? And that's like your perception of like how much you know about X subject. Okay, so starting at the far left, and if you're a novice, you might know a couple of tidbits. If you ask somebody who doesn't know a lot, how much you know about X subject, they'll always pretty consistently like over estimate how much they know about that subject. Oh yeah, I know this, and this. Right? So they think they know a bunch of stuff. Right? Then going to the right, so they're sitting in more classes, learning, reading more books on the material, right? Learn more and more stuff. Right? Their green line score is actually going up because they're actually learning more. Right? But only by the time they actually become an expert, which is the far right side of this graph, expertise. I actually know a bunch of material. Only at that point do these lines actually invert, and they actually underestimate their knowledge. Now, why would that be? Because by the time you actually become an expert in some field, only at that point do you understand all the things that you don't know. Okay, all the unanswered questions about the subject. What those are. It's like, oh man, I really don't know this. Well, maybe nobody knows the answer to this question. How it might connect to a bunch of other fields and subjects that, like, well, I don't know, how does this connect to music? How does this connect to history? How does this, right? You know what you don't know, and then right? Okay, so that's the main takeaway that people normally talk about when they reference Dunning-Kruger effect. It's like, okay, novices think they know more than they do, right? And then the more you learn, the more you actually know. But there's a little bit subtler effect that I want to point out too, which has to do with the slopes of these lines. Slope is like rise over run, right? So if you're walking left to right, you guys see the green line is like a really steep mountain, and the red line is kind of like a shallow hill, like almost horizontal, right? Now that has an interesting implication, right? So the green line, like this 101, so it just says the more you study, the more you know, goes up 45-degree line, boom, there it kind of makes sense, right? What's really unfortunate is that the red line is almost horizontal, because that has to do with your brain perception. So let's say you sit down and you study a subject for like hours over the course of a week, right? In reality, green line says that the more you study, the more you know, like 1-to-1 correlation. But what the red line tells you is that you don't necessarily perceive that to be the case. You don't necessarily get the immediate reward of like, man, I just studied this for like 2, 3, 4 hours. How much did I really learn? And your brain might underestimate the knowledge that you actually picked up from it. Right? You might say like, I probably only learned a little bit, where in reality, you actually learned a lot. Right? So I think it's good to just be aware of this. So if you've been studying something for a long time and you're not really sure if your studies are paying off, they probably are, even if your brain's not telling you they are. Right? All right. Did I pass you guys out some cards? You guys got some orange note cards? Okay. So this is optional. You don't have to do this if you don't want, but you can if you want. If you want to write your name and some facts about yourself, maybe, I don't know, where you're born or what you're interested in or what skills you have or what you want to do in life. Just, right. Do you guys see this grade tray up here? See this grade tray? And so this grade tray, anything you turn in here, it's like a turn-in box. Turn something in there, I will get it. When the bell rings here in about 15 minutes or so, as you're walking out, if you pop that in the grade tray, then yeah, I will yeah, can learn some stuff about you if you want. Again, if you don't want to do this thing, you don't have to, but there it is. Oh, did I tell you guys too? Did everybody write their name in the card in the upper left corner of the desk? Okay, yeah, next to period 3, right? You guys. You know what, too? Maybe another side thought while you guys are jotting down some stuff. I can actually use the Dunning-Kruger as an example, right? Remember I was talking about the slopes of these graphs, right? Now, some of you guys are probably doing calculus class, right? Some of you guys doing calculus, right? And they said that there's tying into physics. There's a connection, right? What is calculus fundamentally about? Like algebra, you guys know it's like solving for x or solving equations or making basic graphs. You guys know trigonometry is like triangles, shapes, angles. Right? What is calculus, like in a nutshell, fundamentally about? It's about rates of change, right? Or at least the first half is about rates of change. Second half is like the reverse of the first half. Right? Yeah, which actually does have a direct tie into slope, right? Slopes of lines, right? It's like the rate change of the green line, well, it's really steep slope versus the rate change of that red line is pretty shallow, closer to 0, right? 0 slope would be like a level floor. Right? All right, there you go. Right, recommended materials. So probably a good idea to have a calculator. Now I do have a class set of these TI's scientific calculators around on the desk. So there's probably one on your desk already. But if you want one at home, so this is the model calculator I use. So if you want to follow along exactly with like what buttons I'm pushing on, blah, 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 like button for button, this is my favorite model scientific calculator. Been using one of these for actually since I've been in high school myself. So planner, definitely use a planner of some kind. If you've never used one before, then hey, you know, we got new beginnings right here, right now. So you know, why not? Could be try something new, and if you do, then can pretty much guarantee you're like, oh man, this is one of the best pieces of advice I've ever taken to actually use a planner. Notebook to keep notes. Yeah, that's good ideas. We're going along in class. We're solving lots of problems up here. If you're writing along with me, then if you write something, your brain will absorb the information better than if you just watch and listen. Well, I mean, there's a couple exceptions to that, but yeah, most people, most of the time, that's how it works. Here's a learning pyramid. Now, I should tell you guys that this right here is not strictly scientific, but this is an adage that has a lot of truth in it. Right? So going from top to bottom, like how much information do you retain from something? Well, someone just lectures something, just like talks at you. Probably remember like a little bit of it, right? Maybe like, right? Now, if you read, that's a little bit more active on your part. You'll remember a little bit more, right? And then as you go down this pyramid, we're looking at activities that are more and more active on your part, right? So we're going to do lots of labs in this class, right? As you guys are like working on labs and teams, right? Help each other out, get your hands on these materials, right? And all the way at the bottom here, teach others. That is actually the best way to learn a subject, is to actually teach it to other people, right? So, and you guys will actually get good opportunities for that in your lab groups, right? When you're doing labs, you can help each other out. Some days these groups, these tables are going to be in group formation, so I'll just turn them into like small groups. You guys can help each other out too. One way I got really good at this class was my job during college was tutoring physics, and so I saw these problems over and over. I had to explain them, and got really good at physics. So there you go. The more active you are in something, better learn that subject. I've got a bunch of demos here at the front. You guys see a couple of shelves here. So throughout the year, I'll pull some of these demos out, show them to you guys. But they're up here for you guys, so you can get your hands on them too. So if you have a spare minute here or there, maybe like coming into class, or if you have an experiment during lab day, yeah, if you want to walk up here and like get your hands on some of the stuff. Oh, I can probably spin this wheel. You guys see this wheel? Right? It has all the colors on it, right? All the colors. So we'll get to optics next semester, but if you put all the colors together, what color do you get? There it is. Do it one more time. There you go. All right, curriculum syllabus. All right, so here's you guys. All right, so you should have this page. Let me double check. Does anybody not have this page? Does anybody not have this page? Okay. Let me pass one back for you. Hold on, all right, honors to you guys. Okay, so you need one. Can you pass one of these back? Oh, can you pass one back? All right, so everybody's got this now, right? Okay. All right, so you guys see down in the bottom right is a Google Classroom code. You see that? All right, so you might have signed up for Google Classroom already. Now I'm recording this right now. I'll make a recording every day, and so I'll post this recording. So if you want to go back and see something again, or maybe you're absent a day and want to see what we did in class, that'll be there for you. There's also a bunch of other materials too. In fact, you know what I'll do is let me pull that up and show you guys too. Let's look at the curriculum real fast here. So next week, I'm gonna hit some review topics, bring everybody up to speed, do an algebra crash review, trigonometry. Those are things we're gonna be using throughout this class all the way to the end. We're gonna be looking at kinematic motion. So this is just, it could be a linear motion, like motion in a straight line. We're really talking about displacement, velocity, acceleration, just things like that. We can also do some projectiles. Right? Then we'll get into forces and Newton's laws. If you push on something, how does that cause motion? Right? Circular motion, so going around a bend, and gravitation. If you put those two ideas together, you might get orbits. Right? So this is like Newton watched that apple fall, seeing the moon going around the Earth. I was like, it's the same thing. Okay? Energy, momentum's like collisions, simple harmonic motions like pendulum swinging back and forth. What laws are governing that motion? Rotational dynamics. By the time we get to rotational dynamics, it's kind of like everything we've done before times two, because it's like, okay, well, what's the rotational context of everything we've seen before? Thermodynamics, materials engineering, waves and sound, electromagnetic spectrum, optics, relativity, quantum mechanics, and electricity and DC circuits. Right? So there you go. There's all the topics we're going to be learning. Hope you guys enjoy learning all these things and get some good stuff out of this. Where's my Google Classroom? All right, now let me switch to honors. All right. So if you signed up for this class, this is this is you guys right here. All right, honors. Let's look at what's up here already. So there's some algebra trig that's going to come up probably next week. I'll break out some of these materials, but they're there if you want to get a head start. But first week materials. So here we are, the first week of school. Your textbook. I do have some physical copies of textbooks back there, but there's a PDF. Posters. So you guys see these posters hanging from the ceiling right here? So that was one of my projects last year. Every year I add on like new labs and have some new project going on. So throughout the year, it's gonna be more and more of these posters added. And I went ahead and just put them all on a file right there. If you want to get a sneak peek. University of Colorado Boulder, interactive physics demos. Actually, this is a good thing to do for homework, is just to like explore these materials and like, go to this website and check out all the interactive demos it has going on there. Right? You guys getting laptops from the school pretty soon, so it'd be a good tool to use on your laptop. Right. I went ahead and gave you guys the AP Physics equations, and also there's some review pages that you guys should have also, but we'll pull out here pretty soon. Right, but all the pages that are on your desk basically are on up here too. Right? Paul Hewitt demos. So there's this old college physics teacher. Actually, he wrote one of the books that back in the corner. I'll break out some of his demos throughout the year. He has a lot of really good, like 1-2 minute long demos that encapsulate Solon physics concept. And there are some of his videos that are on YouTube, but not all of them. So if you want to download these zip drives, and it'd be a good thing to do, look ahead and see a bunch of demos related to this class. Curriculum syllabus, there you go. Also on your desk right now, and the district calendar has all the holidays and stuff on it. Okay, and so there you go. Here's it's on Google Classroom so far. All right, oh, there you go. There, that file's up there, district calendar, bunch of dates. Okay. All right, now you should have some pages stapled together, and this is on the top. Let me make sure that everybody does have this. Who does not have this packet? Okay, this packet. Who else needs this packet? We'll pass one of these back. Do you want these two? So you good? Got one? All right, who else needs this? All right, so everybody's got this? All right. And of course, this is also in Google Classroom, if you want to print out on a printer too. Okay. So these topics are organized about the order that we're going to do them. So what we've got here, on the far left column has the topics named. So kinematic motion, dynamics, so on all the way down, right? Okay. Then the next column over tells you what usually keys you off as to that would be like that category of problem or that category of thinking. Right? So for example, if things are colliding, you guys see Newton's cradle up here? Newton's cradle, right? Like what governs that motion there, right? Well, I see some collisions going on, like point collisions. Anytime you see a collision, it's going to be something to do with this second to last row here, momentum, something to do with momentum conservation. Right? There's some other things too, but third column, what are some common formulas that we're going to use that pertain to each of those topics? Fourth column, what are some classic examples of each of those? And then last column, what are some common graphs that you might see throughout this class? Right? Now, I should tell you guys too that I did format this for my AP classes, so we might not get quite as in depth as some of these. Like some of these graphs, like the second page. Like, am I going to do all this rotational dynamics graphs with you guys? I don't know. Maybe not. But okay. Yeah, so it's formatted for AP, but then I'll adjust from that for you guys. Right? There's some topics missing here, like you don't see thermodynamics or optics, right? Because again, AP actually doesn't test those topics, but we'll go into those topics actually in more detail than my AP class does. Right? How about these last couple rows? Vectors and trigonometry, and so do pretty soon, like break a triangle into components. Based on SI units, how do you measure things? How do you measure mass, displacement, time? Right? What are all the things to measure? Right? What are some basic graph shapes that you guys are going to see? Those are all there. Right? You guys see this page? This is the second page stapled. It has every unit that we're going to use in this class and every variable attached to that unit. For example, R radius could be measured in meters. You can measure the radius of a circle in meters. Right? You guys see that? Right? And so 2 pages. Here's every single one that we're going to use in this class should be on this page. That's a good page to become familiar with because I'm not necessarily going to take class time to write these out like on paper and handwriting, but you have it here. Nice two-sided page. All right, actually, I think that's a pretty good pause point right there. So yeah, next few days, good idea is to definitely sign up for Google Classroom, explore those materials that are on that Google Classroom, and become familiar with those variables, those units, those pages that I gave you guys. All right, you guys ready for lights? Yeah. Lights, lights. Yeah, if you have a card, you want to throw in the grade tray, you toss that in the grade tray, and I will get that. All right, let me end this recording. That is a good first day.